Are we live?
Okay, everybody, we're gonna start now.
Yep, we're fine.
Okay.
Their motto is self-observation. And you look at soldier. So yeah, so you know.
Okay, if I can get everyone's attention. Oh, there's someone. Oh, that.
No.
Are you here for the Python? Okay. Oh yeah. Okay. Okay, if I can get everyone's attention, we're just gonna start the talk now. Thanks for coming along to the Python Glasgow meetup. Yeah, we've got to talk about archaeology. There's a code of conduct and stuff like that as well for members that you can check out. So it's python.scot/code-of-conduct, I think. Double check that. Go on the website. It's at the bottom.
It's on our socials.
Yeah, it's on the social. Yeah.
And the website.
So we'll just begin. So I'll hand it over to Juan just now. Yeah, and you can get started. I'll be around to answer. If anyone's got any questions after, I'll come round with the microphone.
You can just scream.
Yeah, you can put your hand up.
And drop something.
Yeah.
So that's all introduction you want to do.
Okay, I'll just stand up.
Okay. So thank you so much everyone for coming. So this is by far the biggest, thank you Neil, the biggest Python Glasgow meetup we have so far. So that we weren't expecting something, so many people. I was expecting something, so many people. And we were expecting to, yeah, you can hear that as well.
Yeah, buzz. Just turn this off, sorry. It's interference.
And we were thinking to do the streaming anyway, but there's some people interested in see they couldn't make to Glasgow, so that's here we are. So one of the things I want to say is this is not going to be a master class for how to code for archaeology, because only just the developing one tool is going to can take a talk completely. This is more like a proof of concept, so how coding a specific Python can be used in archaeological for works. Before we start, I'll let you, just for pure curiosity, because we have some betting around, how many people is coming here for a more archaeological background? We have one archaeologist on the field. Everyone else is coming from 2 years as well, so 2 people. Everyone is coming from software development, IT, and okay, that's interesting. So because we are interested why we have so much interest in this talk. Okay, so let's start. So why I am thinking, probably overthinking that I'm able to do this talk. Basically because I just move fields from one to the one. So my original background is in archaeology. I was work as a field archaeologist for 6 years in Spain and the UK. When I did my degree, my major was in something called quantitative archaeology, so the application of statistics to archaeology. After many holes dig here in the UK and enjoying the Scottish winter, I moved careers to data science, and I have been working 3 years in data. And when I was working as archaeologist and now in data, I definitely think there is a huge gap between the work in archaeology and the work in software development. That's something that archaeologists can take advantage of. Most archaeologists, they don't think about coding, they don't think about software. We do, especially in commercial archaeology, most of the work is still done in a really old-fashioned way. I was just joking about that yesterday. In 2018, near Cambridge, I was still using film camera because the council is asking do you take photos in color and black and white film camera for archiving reasons. They have the reason to ask for that, but that we're still using that kind of technology. Everything's done by hand, everything's all not taken by hand, and the archaeological companies, they don't really use too much new software advantage for try to speed up the processes. And there's when Python can help to try to make that work easier. And that was the reason about this talk. Basically, archaeology is a data-driven discipline. So most of the work in archaeology is just recording and description, explanation, and interpretation. But all interpretation needs to be based in a data recording before. We produce, especially in commercial archaeology, it produces a lot of data. Thank you so much. From surveys, from maps, drawings, contact sheets, different records, articles, reports, and all the data needs to be done by hand so far. All the compiling, all the processing, all the archiving is done basically manually. That takes sometimes longer to process all that data after when a project finishes than the actual time the people is on the field. That can be quite expensive for the companies. They can be quite difficult, quite hard for the people trying to type in by hand all the information again and again and again. And that's why we are going to use Python. And basically because we are in a Python meetup. So everywhere this was a JavaScript meetup, I was thinking, why JavaScript? Now, basically because Python is one of the languages with simplest syntaxes and is beginner friendly, or can be more friendly than other languages. If you try to use more complex languages, you can see what I'm saying too. There is a wide community. There's many developers in Python. Python is one of the most used languages and one of the preferred programming languages at the moment. There's a broad integration, can be used in any platform because it's an interpreted language. You don't need to compile for different systems. You can write and script and run in almost any operating system. Something, again, this talk was slightly more focused in archaeologists, so this is going to be a bit meh for some of the developers, but basically the data, again, the flow of the data in archaeological research is something that's central to the discipline. So the focus of the central pillar of the talk is going to be different examples, like a proper use cases where the use of really simple Python scripts can help to speed up the archaeological work. As many people here are developers, I think I'm going to go the other way around. So I'm going to invite some of the people, especially the people who is starting Python, the people who's looking for projects, the people who's looking for, the people who's coming from to data analysis and looking for data sets. I would like to invite all of you to look for archaeological problems. They can be quite interesting and they are an incredible example to use in a real life, in a real world scenario. So in a really simplified way, we can, this is a really simplistic explanation of how the archaeological process works, especially commercial archaeology. So basically the first step is this, what is called a desktop assessment. So basically the archaeological company, archaeologists need to write a small assessment screen. Okay, the site we interest, so the area interest this one, and this all the historical background, what happened around, the geology of the site, blah 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 blah, and that's the really first step, and that's sent to the council. Usually, this is part of a development proposal, and the council is going to decide what the next step are needed. If they decide there could be potentially something interesting in the area, you need to move to an evaluation. That can be a walking survey first to see if there's any materials on the surface, or can be usually some actual digging, usually trenches. So they decide there is a percentage of the area, maybe usually 5 to 10% of the area needs to be digged using trenches, and everything is recorded. All the recording is sent back to the council, and depending on what you found in that evaluation, they can decide that that's enough. They can build whatever they want to build, and they don't care. There is something there needs to be excavated, and it's where the actual excavation starts in area. That's an open area. Usually not all the sites, so there is some concentrations out that could be a Roman theme, Roman house, Roman building in that area. So maybe that area is going to be taken more deeper. There is nothing in that area they can build there. Everything excavated is recorded, photographed, drawings, different systems, and all that information, all that data needs to be processed to write a report. And usually what happens is that report is going to be the last and only track and memory of anything that was there, because once the excavation has finished, usually development happen, anything that was still in the field is going to be destroyed because it's going to build something on top. That's why reporting is extremely important. So any data that's lost to the process, doesn't matter if it's because wasn't excavated properly, was recorded properly, or because there was take so long that the reporting wasn't finished. That happens sometimes. All the heritage is going to be lost forever. And that's not only for the owner of the land, so then that's going to be something's going to be stolen for all the, I would say, all the public and all the humanity forever, for the future. Usually, when that reporting is the end of the commercial archaeology part, it's archived, can be archived, and is sent to the council, is archived, for example, in the archaeological data service, and the company moved to the next project. But this when we move to the actual academic and research archaeologists. They need to look for that report, need to compile all the data, and they need to do the analysis to do a broader research. So that's the main difference between commercial archaeology and actual academic archaeology. Commercial archaeology, the company and the teams are moving from site to site just to check if there is anything they can be digging. Something prehistoric today, something modern tomorrow, and they don't really care about what they can find. They need to try to record as much as they can as possible, just to try to preserve everything there. In academic archaeology, each researcher have different interests. So maybe you are more interested in prehistoric archaeology, you need to compile all the reports for different sites about that specific area of interest and analysis. This explanation is because I just try to put together some use cases where for each step, almost each step of all this process, where Python can be used to help the archaeologists to speed up the process. So starting from what we were talking about, the DBA, the desktop-based assignment. As I say, this the basis of this one is just to try to explain what is the background of the area. So you want to, for example, a few years ago, I was called with a friend because near to the Hadrian walls in Clydebank, there was a corner shop. They want to extend the building, and the council was asking for some archaeological monitoring of the area because it was too close to a World Heritage Site, the Hadrian's walls, so they couldn't just give permission without that. So the first step is just to say, okay, what we have around. In this case, it's easy. Okay, we are in the buffer area of the Hadrian's wall. So we have the Hadrian's wall. We have different, for example, we have Second World War stuff near in the area. And we have other industrial stuff as well. We have all maps. We put all together. I report the screen and say, okay, this is all the information we have. This is potential going to be in the area. CAMOR is a service for the National Historical Service for Scotland. When they record, it's a database of archaeological and heritage sites and historical sites in all Scotland. And something really nice they have public available all their data in SHP files. I don't know if anyone is familiar with SHP. SHP is the GIS, the Geographical Information System format. So basically, you have all the locations with the coordinates for all. We are talking I think a few 100,000 locations, places in all Scotland. So using a quite simple Python, all the examples are in a GitHub repo. So I don't want to, because I don't want to just to be showing all the code all the time. That can be something overwhelming. Again, I was speaking to more archaeologists than computer people, but you never knows. But in this case, it's really simple. Locally, just to run a Python script that just taking the coordinates of the site is able to give to you in a buffer of, in this case, 100 meters, anything that's around of that place. So, and that's pretty simple. Takes 9 seconds to run, and is just, you only need to write once, but you can change the coordinates every time. This is quite simple because all the examples I'm explaining here was done in a couple of hours, but there is no limit about what else can be done on top of that. You can use, for example, the Camor website. They have more information than the actual database they share the files. You can do web scraping because you have the URL, the path, the address of that record. So you can do web scraping to understand what you're talking about. You can plot the information. It's something we want to do before, but you can actually do plottings. You can automatically do the maps around. You can even use some simple natural language processing process to do summaries about what you have around. So that means that, yes, inputting the coordinates, you should be able to have all the summary about all the historical background of your desktop-based assessment in 10 seconds. By the way, for anyone who knows, and script, as a word I want to be using a lot, is just a short program that's going to automatize a task. So I guess everyone here knows what is a script, but just in case. For example, really similar, the geology of the site. So there's another part of the desktop-based assessment is to know what kind of geology we have, because depending on geology, there's different preservations, and it's just part of the desktop base. It's the same kind of idea. The difference is a different format. The British Geology Survey service provides in a different kind of database, but it's exactly the same process. For this example, I'm using what is called the 625K database. It's a quite broad one. There is other databases where they are much finer and they have more details, so you can know better the geology of the nearby area of the location. And again, it's possible to use natural language processing to do summaries of the information, have actual text at the end, say, okay, this is the geology of the area, you can expect this kind of rock, this kind of sand, that's the surface, because depending on that, so maybe the strategy of the council is going to ask for something different. If you have clay, for example, maybe they're going to ask you go deeper. If you have more sands, they can go through different kind of strategies. Moving to the next step, one of the things needs to be done once the council asks you to do the evaluation. You need to put trenches on a map. They need to approve the location of the trenches. They can build places by hand, and that's quite time consuming, especially when you have a huge area. You have usually this 1.50 meters, 1.5 meters wide by 50 length, and you need to in CAD using GIS, you need to copy and paste the same square again, and that's a few hours of work. Using a small Python script, just giving the coordinates of the outline of the site and all the information about the length and the width of the perfect trench, is able to calculate how many trenches you will need to use, how many space you will need to be between them, and place all of them in an organized way on the map. Again, this is a quite simple example and it works. You can see this is an example. So this is a real site, but this is a park near my flat. So this is like this site, and this is all the trench locations. Right now, this is how far I went in a couple of hours. There is few things that need to be improved. So the behavior of the script when it's close to the border can be improved, because if you see the trenches are cut, and I wanted to have them rotated, and as well I wanted to try to discover what is the bigger axis on the site and try to orient it in that way. But yeah, that's something that even having something so simple like that in 20 seconds and just to do few improvements by hand can save a lot of time for some archaeological companies or archaeologists. And again, it's something that's going to take 20 seconds to run, and if it's a tool that is available on the internet, the archaeologists know how to use it, they can reuse again and again and again for any purpose. Moving to the recording, let's say that all the evaluation has been finished, and we have a lot of paper records that need to be put all together. Usually, especially in big projects, what happens is that all the team members just take a laptop and start to type and record all all the information in a spreadsheet, and all that spreadsheet needs to be put together in Excel. Again, how it has been done for years is just someone in Excel copied and pasting information again and again and again. We are talking probably at least dozens files that all the data needs to be checked by hand and put in the same format. And again, it's something that can take a few hours for someone work. There is a simple script, and I guess that everyone here who works with Python knows that's not so difficult to do. Just to be able to take all the spreadsheets, put in the same pandas data frame, double check that the formats are right, able to double check if there is any missing information, and all the records are fine. Be safe in one file and just save all records or incomplete records in a different file, so they can be fixed and they can be fed again to the system. For example, only took like 3 seconds to put together more than 1,500 records. That's something by hand can take a few hours of work. I know that this looks banal for most of the software developers we have in the room, but this is something that is done by hand today in the industry. The people is getting paid to do that by hand and waste time for doing that by hand again and again and again. So that's the situation. Well, it was a situation 2 years ago when I left the field. Moving something slightly more modern, we go to LLMs. It is possible to use some LLMs. I was just doing some experiments using the vision models. So be able to transcribe the content sheets they are creating by hand. So be able to automatically take picture of the content sheets, extract the data in a JSON file, and put the data in a database or in an Excel file if that's what you want to. I assume that almost everyone here knows what an LLM is. If not, it's just basically the models like ChatGPT. Problem with that is they are stochastic models. They can have some issues. They can sometimes hallucinate. So there needs to be some words need to be done to avoid that. Some dictionaries needs to be produced to try to control that hallucination as much as possible. But for example, using locally, only Gemma 3 with 4 billion parameters, quite a small model, and 30 seconds I was able to take the data from this example of a content sheet created by hand to a JSON file. It's another thing that can be done, and I'm pretty sure that's something that more research is going to be done in this area soon. Another classical is in archaeological works, we take a lot of pictures and they need to be processed. Some of them are entered in the reports, some of them not. So usually, again, the way to do that is just to choose the picture you want to use for the report, paste in the Word file to modify a hand, and you can do that maybe 10, 20, 50 pictures. The example I use a small file with register all the files, all the pictures, and on that CSV file, on that spreadsheet, you can say, okay, I want to use for the report this one, that one with this title, and automatically the script is going to take those pictures, save in a Word file with the format that you need to do for publishing, and have the title you need. So that means that you have this, for example, so all these pictures where they look slightly, because there are 2 different pages of Word file, they're slightly modified, but they were just random pictures, and they just put in a Word file with the title, with additional information for the Excel file. Again, that's something if it's done during the actual recording of the pictures, or just doing quite quickly when the process of doing the report can be done automatically, and you don't waste all the time with someone just putting the picture, try to put everything on the right format. They can be used as well for sort the pictures by folders by the date, or by trends, on using different metadata details. Some cameras and the phones, they can have GPS details on the metadata, so they can use that for example, to locate automatically which pictures are related with the area, specific areas on the site. And yes, moving a bit more for the research and academic area. For many industries, and I had the feeling it was like a few years ago when I left, for many industries, a database is as a folder full of Excel files. And in the case of archaeology specifically, usually we used to have different tables with common columns, but they're still different files. So everything needs to be manually matched by hand using lookups and all the simple functions in Excel to be able to match. This is the photo, this is the context, this is the finds record, whatever, and if it was for the report. Obviously, there is a better solution, and again, this was more for archaeologists. There's something called database, relational databases. They can be done in SQL, and that relation is done automatically. This is a quite simple example. This is a data set. This is from the Archaeological Data Service. It's just a catalog of bronze axes. So basically, it's different, about 8,000 bronze axes from the British Islands, and different details. So the original files are 3 different tables. This is the main table with basic information about the objects. You have the radiocarbon table, the elemental, about the different elements of the objects, and the isotopic analysis. But all of them have the same column. This is called artifact ID. That's what is going to be the primary key for the main table and the foreign key for the other tables. So if we put all together in a SQL database, and that can be done using a quite simple Python script, you can do much more complex queries. So for example, if we want to say, okay, what's the average lead content of the objects per site? That's something that if you only have the Excel files, you need to do lookups, and it's a much more complex process. If you have everything in a SQL database, it's only this quite a small query, and you have the information straight away. For example, what is the average ratio between the 2 different lead isotopes for each different type of objects? Again, using that query, you have the information. So that can make every researcher's life much easier, because they have the access to the data immediately. They need to do all the relationship, and you have to be checking here and there. And that saving the information in that SQL database can be easily done by a Python script. Moving forward, what Python is better known today is for data science. And even when you can do basic statistical analysis using Excel, that's not the real way to do the thing. So if you want to do something that's slightly more powerful, or you want to have more control about the statistical analysis and the tests you want to do with your data, you need to use something slightly more complex. In this case, Python is one of the main tools used for that. This, for example, I'm using a PCA, a principal content analysis, for the isotopic composition of the different axes, and on top of that, I was using some clustering just to see the different groups. This is cut, on both sides, but basically this axis has the biggest variance and explanation, so that's the most important axis. But yes, basically you can see how the different axis groups are marked, and that one is the same process, but instead of using the composition of the objects, is using the dimensions, the length, the width, and the thickness, and you can see like different clusters. But of course, using Python, you can go one step on top of that. So you don't need to go to a different program, GIS, maybe process to a CSV file, input the layer, put the background and everything, and repeat that every time you want to do a map. You can automatically have a workflow in Python that produce maps that you are happy with, and you have this kind of again, this is quite simple examples, but it's just all the axes on the data set plotted, the different composition clusters for areas and the different cluster for dimensions. You can see, for example, the composition is quite different depending on the area. I don't really like the colors, but all this color has the grayish cluster. The pinkish cluster is more in whales and kernels, and if I remember properly, I think they have other cluster for Suffolk. But yeah, that's something that's much more simple to do using Python, that just moving different software solution for each one of the steps. So that was the last actual use case and example that I have actually tried. And again, that's going to be available in a GitHub repo that we are going to add to the YouTube video. I need to send to you the link. You have the examples there, but there is much more that can be done, and that's something that I invite all the developers here. Try to find an archaeologist. Usually we're nice. Usually we don't bite, at least not always. But there's just a few random examples I have to take some things that can be quite helpful. So for example, use labels, article labels. Everyone knows what article labels are. So are just simple QR codes that can be used for automatically embed some information in the pictures. So you can add that to the picture, maybe in the photo board we use for the technique pictures, and automatically use that for giving information, add more metadata to the pictures, or maybe try to include that for avoid distortion in the picture. So for example, you have something in 90 degrees in a specific scale with that labels, automatically you can write a Python script that takes that points, notes the distance and the priority between them, and modify and transform all the picture in base of that one. That's something that I have done by hand using different points in a wall, but there's something possible to do automatically. For example, another random idea I found is use Telegram bots to send information back to the office. Maybe just to send pictures and some basic information. Maybe use more conversational bots to be able to ask questions. So, hi, what is the context number? That's the number. Okay, what's the description? What's the drawing number? So you're able to input all the data, send the pictures, and all information can be sent to the office directly. And of course, if there is another Python, because that can be done by Python, if you have a Python script or system in the background, in the backend, receiving that information, you can automatically save that data and even start to create a report. So you can, all the process can be done in few automatic steps. Of course, more use of LLMs for reporting and the space writing. So be able to use automatic workflows and different kind of LLMs to create more and more part of the report. Because again, this is scientific and technical documentation. This is not something creative. We are talking about actual novels. It's some technical documentation. This is a site. This is the trenches. That's what we found. We move to the next one. So there's something that can be done really easy with a LLM, and we are not to lose any kind of artistic theme on that. Of course, all the examples I'm talking about are using command line. So you can be use some graphic interface or web interface using different libraries. You can use the development of a web application. Yes, remember, for example, some of the sites are not don't have internet connection available, but there's something else that can be done, and can try to spread even wider the use of technology. Finally, and that was the actual idea why I was giving this talk, is the creation of open source community tools. Say, for example, the examples I'm talking about are in a repo, and they are today available for anyone that wants to use them. They are just proof of concept. They are not really something that can be used for a professional way, but if more people start to be interested in this kind of topics and more people interested in developing this kind of tools, we can produce a community of open source tools, and developers, they can try to help each other have the tools, and that means that we can start to move through some kind of standardization about these processes, and we can start to bridge that gap between academic and commercial archaeology. And yep, that was me. I don't know how. For 35 minutes. Okay, that was fine. So that was me.
Perfect. Okay. To this one, transition away. Okay, so just yeah, this mic's working. I think test. Yeah, that's yeah. Okay, does anyone get any questions at all? Hands up.
Not everyone at the same time.
Oh, there we go.
Yeah.
Microphone.
For the example that you gave with the field notes which were handwritten and then scanned or transcribed or digitised, are the original handwritten notes kept or are those thrown away so it's only the digital translation that you keep? Because the original material, in a sense, could be have archaeology applied to it again decades from now with better LLMs and all the rest of it.
I mean, of my personal example, this is an example to have I use, so I don't know real content sheet having heart in that experiment. But I mean, usually that depends on the archiving and the council. So some, I mean, really, I don't really know right now what's the process now, because I think that depends on the council. Some council ask you to keep more physical stuff. Some councils, they only want to have the final report. Most of the information of that content sheets are anyway digitalized. Right now it's typing by hand, so they can be done. It needs to be typed by someone, and all is an Excel file, and all that is safe. So I don't think, I guess the actual papers records are safe for a few years and after that destroyed just because they don't have, just for space reasons. But yeah, that's a really good point. That's something I was, when we were talking yesterday about the use of film cameras, that looks anachronistic, but at the same time, if are stored properly, that picture are there. If we have here many times when the different systems are broken or something happen and data is lost. So in that happen, and you need to have a proper backup strategy to avoid that kind of things. When you have a proper physical object, you can just keep in a secure way and just so that's a really good discussion, and that's something that needs to be addressed for sure. So that's a good one.
Oh, here we go. Okay. Any other questions from anyone else? Oh. There you go.
Just speak into it like this. In your second or third example, you showed how you could look at a site map and then draw a map of trenches to be dug. And the example you showed was quite a regular array of trenches. Are there certain techniques that you tend to use in archaeology for laying out the trenches in a certain way?
Usually they need to be regular because you need to cover all the area in a regular way. So try to avoid any bias because you are sampling randomly. It's like a standardized sampling of the systematic sampling of the area.
Mm-hmm.
So there's not something like for this kind of evaluation trenches, you try to be as regular as possible because you try to cover as much area as possible on the extent that they need to.
Okay.
So there's no actual technique. Of course, if you are talking about research excavations and they are looking for something specific, they can use geostatistics to try to see where is the most important, or where they have the highest probability where you can find what you're looking for, and maybe you can dig the test pits in that area. But that's something different. In this case, usually they're as regular as possible. Mm-hmm. So you try to avoid to miss any gap.
Yeah.
Mm-hmm. Usually that depends, but I think it used to be 5%, 5 to 10% of the area. That depends as well the council of the area. So if you are looking for, you're in a really sensible area, maybe we can ask you for more area sample. If you are more just to check if there's anything there, it's less area.
Thanks.
Okay. Seen you first there. The mic's on top, just the light is.
In terms of usability for different archaeological units, do you see this being most beneficial to field teams, to post-excavation work, or primarily like the writing up of things and doing reporting?
I think probably for post-excavation teams. So usually, yeah, I would say post-excavation is usually the people is going to be more because are the people actually typing and record and transcribing everything to the computer. Field teams can, yeah, I don't know if that's going to be, sorry. Field teams could be beneficial as well because they can have, some of the tools can improve the way to record and send the information back. Maybe we can avoid to do actual any writing on the field. Maybe we can just send by phone the information. That could be something helpful. Again, I don't know if that's a really good or bad idea for archiving process, but that's something can be done. And at the end, I think it can be different. Each team and each the person working each step of the process have different challenges, and I think the Python is just Python or any kind of coding can be a tool to try to automatize and help them to some of the work and challenges they have. So that's why I try to do as example as broad as possible. So I don't know if maybe the field teams they have a challenge that I just don't remember or can think about that can be really easy done by using coding. So for example, timesheets, recording, some more administrative works, there's something can be speed up as well by using coding.
Any other questions?
So a lot of things you showed, it's about having cleaner processes, managing data more efficiently and stuff like that. Do you have any example where you can actually use machine learning or LMMs to drive the research for archaeology? You know, say, oh, we have this kind of, we made this kind of finding in this kind of places and we find correlation and then we can estimate where we should search next time?
I mean, I do have the examples, not here right now to show, but I know the examples. The thing is, we are talking about two different kind of disciplines. When everything we call archaeology, when we talk about archaeology, archaeologists usually they don't dig by the settlers looking for something. They are trying to explain a process, and they dig just to try to find more information to support that hypothesis about that process. So that's why they don't just dig to see if they found more medieval stuff here or more Roman stuff there. But they are looking for, that should be the ideal way to do the archaeology. So they are looking for different commercial routes of the Roman Empire, blah, blah, blah. So they are looking for that and they are digging depending on that. That you can use machine learning, have used machine learning, for example, to trying to predict the probability or the density of materials in some areas and use that for digging in that specific area to test and try to map the different routes, for example, something has been done before. On the field that I'm more familiar with, most of my research is in Paleolithic. We use statistics and machine learning almost for everything. The thing is, we don't have so much data, so we need to use more experimental data. That's something as well can be used. And again, machine learning is used every day next to the statistics. So, for example, one of the projects I was part of, we were looking for trying to identify for cut marks in bones what was the raw material that was leaving that us. They were using a metal knife, some kind of flint knife or whatever, and the way to using the shape of the mark, and that was done using machine learning. So yeah, it's one more tool that I use a lot. About the use LLMs, they are not really used too much at the moment, as far as I'm aware of. But I think it's going to start to be used really soon. At least, I mean, when I say they don't use too much, I'm pretty sure that 90% of the units are using ChatGPT to writing stuff. I don't have any proof, but I have a little bit of that because we use for that every day. And that's something simple. This is the data. I have used that for report as well. This is the data. Write me a report for that. And there's something that ChatGPT is really good at that. The main difference using something more automatic is you don't need to use copy and paste different platforms. You have a workflow that everything works in a way. Yep.
Like you using vision models at all with recognizing objects? Or
I use visual model in the example of the contest sheet.
No.
That was a visual model. Probably can be used for more. The only thing about the LLMs, not LLM, about machine learning in general, is that archaeology usually we have really small data sets. We don't have too much data. We can have huge experimental data sets. That's what we need to use. But for example, if we need to use visual, not that element. Let's say, for example, we use a visual transformer for a deep learning system for classified pottery, for example. The problem you're going to have enough pictures of broken pottery, and the variability is so high that it's going to be. That has been done in the past. I remember, for example, in 2019, I was giving a talk about. There was a few talks in Rome about machine learning in archaeology, and one of the projects they were using drones to do like surveys of the area. That, for example, works quite well. But if I remember properly, they were using that on Greece. That is a quite dry area. I don't know, for example, that's going to be so useful in England, for example, in the UK, sorry, because it's much greener and you have much more vegetation. But yeah, that has been done.
Cool. Is anyone else in the question? Nikki in the YouTube chat mentioned that they'd still save context sheets. So I'm reckon someone asked about that, I think.
Yeah, there is someone in the chat saying that they save their context sheets. Yeah. Yes.
It was just inspired by that point there about the drones that the team was using drone aerial footage. And on a related note, in archaeology, are you making use of satellite imagery and data analysis on top of satellite imagery, like image or visual ratios, that type of thing, visual indexes to look at areas that are maybe more likely to contain archaeological interests?
It is used more and more. One of the tools we use more is LiDAR, the LiDAR maps used for satellite images. And if I remember properly, and I think Scotland, historic Scotland was asking for the DBA to be some LiDAR analysis as part of that. So we are using that more and more, especially because the tools are becoming more and more accessible. Right now, you have websites, so you can just go to the website and look for a LiDAR map, and it's quite easy to find the data. Before that, it was a bit more difficult to find the data, so you can ask for everyday archaeologists to be able to go and find the data. But yeah, that's something that's used every time. And I'm pretty sure that the use of different deep learning models on top of data analysis for the kind of satellite images is going to be a really huge factor for finding new archaeological sites.
Cool. Anyone else get any more questions? We should wrap it up there. Yeah. Nice one. Okay. All right. Well, yeah, we're going to wrap up the talk there. Thanks for sitting in one time there. Everyone enjoy that? Yeah. Learn something new. Okay.
That's
cool. So after this, we're just going to stop the stream, things like that, and then you can sort of network around and things. There's still plenty of pizza through there. Everyone's still hungry.
Pizza.
Yeah. Yeah. So we'll stop the live stream now. So thanks everyone for tuning in on YouTube.